Today, I'll be teaching on the cumulant generating function. So a cumulant generating function is a function that we use to generate, we can use it to calculate moments, the crude moment, central moment. So the same way we use moment generating function to generate moment. My last video, I explained the moment generating function of a normal distribution. So today, I'll be teaching on the cumulant generating function. So we're going to use K x t to represent the cumulant generating function. And the cumulant generating function is the log of the moment generating function. So I can also represent it as log E. We know that mxt, that is moment generating function, is express value of E t x. So this is the cumulant generating function. One thing you know about the cumulant generating function, the first cumulant will give you the mean, which is the express value of x. The second cumulant will give you the second central moment, that is the second moment about the mean, which is the variance. Also, you can write this second moment as, you can also write it as the value of x minus the value of x all squared. So this is x. Then the third cumulant is the third central moment, which can be written as the square value of x minus the square value of x all raised to the power 3. The fourth cumulant is mu4, which can be written as mu4 minus 3 mu2 squared. And you can write this as the square value of x minus mu all raised to the power 4 minus 3 square value of x minus the square value of x. So this mu here, I mean the square value of x, all raised to the power 2, then you square all this. So this, I've written the first moment, first cumulant, the second cumulant, third cumulant, fourth cumulant. And you can see that the cumulant, the first cumulant is similar to the mean, which is the first moment about its origin. The second cumulant is similar to the second moment about its mean, which is the variance. The third cumulant is similar to the third moment about its mean, while the fourth cumulant is equal to the fourth moment about its mean minus 3 times the second moment about its mean all square. So I just gave you a note on the first cumulant. So now I'm going to show you how to get the cumulant generating function and how to obtain the cumulant. So now I want to show you how you can get the cumulant generating function and how you can estimate the cumulant. Remember what I said about cumulant generating function? I said cumulant generating function is what? Is a log of the moment generating function. And we know that the moment generating function is a square value of E t x. Let's use the moment normal distribution as an example. So if x follows a normal distribution with mean mu and variance sigma square, we know that the f of x is 1 over sigma square root of 2 pi e raised to the power minus half x minus mu over sigma square minus infinity less than x less than infinity. minus infinity less than mu less than infinity. And we know that sigma square will be greater than 0. In my last video, you can check that on my YouTube channel. My last video, I estimated the moment generating function of the normal distribution, and I said it's mu t plus half sigma square t square. So this is what we got as the MGF of a normal distribution. So we estimated the MGF of a moment generating function of a normal distribution. So I want to calculate the cumulant generating function. So what is QXT of the normal distribution? Expected value of, log. Don't forget to like this video, share this video, subscribe to this YouTube channel, and say something on the comment section. So we have log E mxt, and we already know the mxt. We know this as this, so we can replace this as log E ut plus half sigma squared t square. So this is the moment generating function. So what will happen? The log E will cancel out E. Remember, log 10 base 10 is 1. Log 2 base 2 is 1. Log 2 power 5 will be 5. Log 10 raised to power 4 will be 4. So similarly, log E raised to power 4 will be 4. So this log E will cancel out. Log E will cancel out the E. We're left with mu t plus half sigma square t square. So that is the cumulant generating function. So for you to get the cumulant generating function, you want to start from the beginning. First, you have to get the MGF. When you get the MGF, you take the log E of the MGF. Now, I didn't solve the MGF of a normal distribution because I already have a video for that. So check my previous video, check my YouTube channel, search for the MGF of a normal distribution. You will see that. So first, if you are asked to look for the cumulant generating function, get the moment generating function of that distribution, then take the log E of it, that is the cumulant generating function. So therefore, KXT, which is the cumulant generating function, is mu t plus half sigma square t square. So remember what I wrote earlier. The first cumulant is the mean, second cumulant is the variance, which is the second moment about its mean. The third cumulant is the third moment about its mean. The fourth cumulant is the fourth moment about its mean minus 3 times the second moment about its mean all square. So let's check this out. So let's differentiate. Let's get the first cumulant. So to get the first cumulant, you differentiate the cumulant generating function once. If you differentiate this with respect to t, you will get mu. If you differentiate mu t, you will get mu. If you differentiate the second object we have there, you have, with respect to t, you bring down the power, which is 2, and subtract 1 from the power. So this will give us mu plus, so 2 will cancel out 2, 2 will cancel out 2. We'll have sigma square times t. Now, if I equate my t to 0 after differentiating, so I equate t to 0, I will get mu plus sigma square t equate t to 0. So this will give me mu plus sigma square times 0, which is mu. So I've used the cumulant generating function to estimate the first cumulant. And the first cumulant is mu, which is the expected value of x on the distribution. So let's get the second cumulant. So to get the second cumulant, I will differentiate the first cumulant again. That means I'll differentiate the cumulant 2 times. So to get the second cumulant, we differentiate the cumulant generating function twice. Or differentiate, which is same thing as differentiating the first derivative, differentiate it again. That's what I mean. So after differentiating the first time, this is what I got. So this is what I got after differentiating the first time. So I have to differentiate that again the second time. So k xt means differentiate mu plus sigma squared t with respect to t. So if I differentiate this t, if I differentiate mu, I will get 0. If I differentiate sigma squared t with respect to t, I will get sigma squared. So the second derivative of the cumulant generating function is sigma squared. Remember, this is the second cumulant. This is the second cumulant. And like I explained earlier, the second cumulant is the second moment about its mean. So that's it. So then the next step, you equate t to 0. Equate t to 0. We'll get sigma squared t to 0. Because we don't have any t attached to sigma square, the answer is sigma square. So this is how to get the first moment, the first cumulant, the second cumulant for a normal distribution. So first I obtained the cumulant generating function of a normal distribution, and I used it to get the first cumulant and second cumulant. Thank you. Don't forget to like this video, subscribe to this channel, and also share this video. If you have any topic you want me to teach, you can say that on the comment section. Thank you.